even turn on the projector. Oh, yeah, I got it. Y'all been good over spring break, weren't you? Okay. Nah, okay, don't answer that question. Okay. All right, a couple of announcements. And this one's fairly important. I can't remember if we did it last Wednesday or not. I don't think I have the data yet, but whatever. Informational sessions are happening concerning institutional scholarships and summer Pell, not today, not tomorrow, but Wednesday, day after tomorrow, Wednesday. 2 times, 11 to 1 and 5 to 6:30, okay? All on Wednesday. They're going to be on both campuses. On this campus, they're going to be in the faculty staff dining room. Now, how you get there from here, or from wherever you are, you go out this door from here, you can come in from here. Okay. You go out the door here, and you bump into the great door. Okay. Don't go to the first stairwell. Go to the second stairwell. About 2/3 way down the hall. Go down half a flight, not the full flight, half a flight. Go into the little hallway here, make a couple of twist turns, and then as you go toward the cafeteria, the faculty staff dining room is on the left. Okay? Sort of across from that room that's sort of the rec room or whatever they call it. Right across from there is the faculty staff dining room. That's informational sessions concerning institutional scholarships and summer Pell. Okay. Now, I was told by a student this morning that they had summer Pell last summer. I didn't know that, did they? Do any of you know about it? Okay. They got it this summer. In other words, if you have done your FAFSA, completed your FAFSA, and it's come back, you can start using Pell this summer. You don't have to wait till the fall to start using it. Now, always, if you had any money left over from this year, you can use that too. But you can start using, if you used up all your Pell Grant fall and spring, you can start next year's this summer. Okay? That's something fairly new. They had it about 7 or 8 years ago for 1 or 2 summers, and it worked so wonderfully well, they decided not to do it anymore. I don't know. I mean, I think it was budgeting and stuff like that. But anyway, they started it back again. Now, the institution, Lawson State, has always tried to save up scholarship money and collect money from our various sources and then provide some scholarship over summer because Pell didn't used to cover summer. Well, now that Pell's back in, that means that scholarship fund won't have as many requirements because more students will be on Pell, so there will be more opportunity for you to get more courses covered. If you're not covered by Pell, you can use the summer scholarships. So go to these sessions coming up Wednesday and find out what you can do. Now, I told you where they're going to be on this campus. On the Birmingham campus, they're on the West campus, the Leon Kennedy Center, that's sort of the student center now, and it's in the cafeteria, which is on that first level, which I find pretty interesting because 11 to 1 is lunch hour, and you would think the cafeteria would be pretty busy then, but evidently they're going to have a little section of it that they'll have for this program. And then 5 to 6:30, the folks in the dormitories, I think their supper hour, but that's going to be a much smaller crowd, so I know it won't be a problem doing that. Office of Student Financial Services is planning this and putting this on, so please go. Find out the information. See if you can apply for a summer scholarship. The deadlines are going to be coming up really soon. It seems like April 15th may be the deadline for that, so please go to this session. Now, if you're going to do your Pell Grant, hopefully you've already got that done, but if not, get working on your FAFSA for next year because you can start using that money this summer. I've told you about the math team before. They meet Monday afternoons at 3 and Fridays at 12 noon on the Birmingham West campus in C100. That's the science building, C100. I've told you also about tutoring on this campus. If you go down the hall here, like I said, that second stairwell, don't go down the stairs, hang a right. and that's the tutoring lab. Now, if you don't see anyone there, if it happens to be locked up, go all the way to the end of the hall, hang a left, and the last office on the right will be Student Support Services main office. Check in there, and they will let you know, line you up with whatever you need to do to get tutoring as Student Support Services. Now, if you want to use the Space Center, go down to that second stairwell, just like we did before. This time, go down one full flight, not the half flight, but one full flight. As soon as you come out of the stairwell, hook back around. Room 105 is the Space Center. It has a big sign over it, and they have tutoring there. Okay, so take advantage of the tutoring. And if you have done well in a course, A or B, any course, and they need tutors in that course, you can probably sign up to tutor. That's true in Student Support Services and there. Okay, I shouldn't have this piece of paper in here. It should be with my last class. I picked it up by mistake. All right, a couple people did come in. Greg Joy and Al. I think it was Al. It's been so long. I'm just kidding. Okay. All right. Okay, I hope everybody had a good spring break. I think I got all your grades entered. It was this morning, but I think they're all there now. The next class, no, I got the 112, 113, 125. I didn't get the physical science and physics grades, the newer grades in, so I'm still working on those. Won't have much time today, but maybe this evening. All right. We will start from current slide. We are recording, and this is where we're going to pick up from last time. Now, I don't have a mark on the page, so I think we're beginning in 13.3. Is that right? No one remembers. No one remembers anything. The spring break was too long, wasn't it? Okay, now, I am so embarrassed that I've forgotten. I think we talked about, yes. Say this again. Yeah, that's what we're going to be doing. But I forgot because we lost class last Monday, the Monday before spring break, because of the weather, severe weather that never happened. We talked about making up that class in pieces. Now, we meet for an hour and 15 minutes each, and this is Brianna, right? Okay. What we could do is, let's see, an hour and 15 minutes, that's 75 minutes. What we could do is 45 would be pretty close. No, that'd be 90. 40. That would give us. If we started, and we talked about this, but I think someone said, why don't you put it on Blackboard? And I don't think I did. I don't think I had a chance to do that because right after this class I go to the Birmingham campus, and then I had classes all day on Thursday and never got back. So, didn't I ask if any of you would be available to come early? And didn't you say everybody pretty much would? Or not? You may not have been in here. You wouldn't be able to come early? Monday or Wednesday. Say again? I'm sorry. Yeah, Wednesday of this week and Monday of next week, say. You can't do it? Okay. Yes. Okay. If we shot for 40 minutes early, we start, that would be about 12:20. Could we do that? Anyone can't do that? Some of you are here. You can't? You can? You don't think you can? Okay.
Did you say what? I thought it was 1:30, 30 minutes early.
Okay.
So you said 12:20?
Okay. I'm sorry. I meant 1:20. Sorry.
Oh, okay.
1:20. We could do it 3 times if we did. We could do 30, 30, and 15 if we did it 3 times. I think that's what we talked about before, or we can do it twice. Let's go back to that. Then we can do it this week and next week then. You want to do that? 30 minutes early. Come here at 1:30. Do it Wednesday, 1:30 on Monday, and then 1:45 on the following Wednesday. You want to do it that way? That way it wouldn't be as long. Okay? All right. If I'm not up here, someone go down to my office and remind me, because what I'm doing is entering, like today I was grading papers and putting things on Blackboard. And I couldn't, where I was over spring break had really lousy internet. It was DSL, very slow. If things would time out on me, I just gave up. So anyway, I should get caught up, if not this afternoon or evening, tomorrow morning, hopefully, but we'll see. Okay? So let's plan for Wednesday to meet at 1:30. Next Monday, we'll do another 1:30, and then on Wednesday of next week, we'll do a 1:45. Okay? Let's plan for that. All right. Yes, and this is, I don't think we got started on this section last time. Any questions on anything we've done up till now? Okay? Our objectives for this section, multiplying polynomials, we're going to do several ways. First, multiply a monomial times a polynomial. That's pretty simple, right? Then we'll multiply 2 polynomials together, and if they're both binomials, we'll use the good old FOIL method. Everybody know that already, or anyone not? Okay, we'll go over that. And then we'll cover any 2 general polynomials beyond monomials. Okay? So, they jump right into it. They don't even give you the any slide here for it. How in the world would we multiply a monomial times a binomial? Say again? Yeah, distribute it across the parentheses. Okay? So basically what we do is multiply. Whoa, let me get my pen activated at a darker color. We'll multiply these 2, then we'll multiply those 2. So when we multiply the first 2, do the numbers first. 5 times 6 is 30. And then do the variables. X squared times x to the 4th is x to the 6th, did I hear? Excellent. Y'all remember it. Spring break didn't wash it all away, okay? And then let's do the second one. 5x squared times 7. Do the numbers first. Plus 35. And then the variable, x squared. There's nothing to multiply it to. There we have it. Does that make sense? Does everybody see what's happening there? It's just distributing across the parentheses. And remember how to do this. Multiply the numerical parts. And then if you have same variables, different exponents, keep the variable, add the exponents. Okay? And we have just a monomial times the number. Just multiply the number part and then keep the variable just like this. Does that make sense? Yes?
Where do you get the 2 squared from?
Where did I get the what from?
X squared from that.
Okay.
Where did you get X squared?
X squared. 5x squared?
Oh.
Okay. Oh, yeah, okay. You mean on the
Yeah.
last term?
Yeah.
Yeah, 5 times 7 is 35. X squared times 1 is x
Oh,
squared.
okay. I see.
Okay? Yeah. Good question. I thought you meant where I got that one. They gave it to me in the problem. Okay, no. Okay. All right, let's see how they do it. First, they're going to distribute. Oh, boy, look at this. They fancy with it. They do the 5x squared times 6x to the 4th plus the 5x squared times 7. Okay? They're stringing it out a little bit. So then they're going to do 5x squared times 6x to the 4th, and then they'll do it just like we said. 5 times 6 is 30. X squared times x to the 4th is x to the 6th. Let's see if they do it that way. Yeah, well, they don't take the time. They rush right into it and do it. 30 x to the 6th plus 35 x squared. Make sense?
All right, good deal. And that's the answer. All right. Now, and by the way, this is on the slide. We have example 1 in the book is slightly different, so that's something you need to do on your own. Make sure you understand it. A and B there, and then in the side margin, they have some additional exercises, A, B, and C in that side margin. Okay? So let's do the B part. So what would you do first? You tell me. Okay, distribute here, and what does that give you? A little louder. 6. H to the what? I can't hear. 13, okay. All right, 4 plus 9. All right, good deal. Next. Was there a sign in there? Minus 16. H to the, a little louder? 6. Got it. Thank you. And then finally?
2.
Second?
2 H to the 4.
Is there a sign in there?
No.
Yeah.
Well, it was negative, but
Yeah. Negative times negative is plus. Don't leave off the signs. You got to have them in there. It's going to be a polynomial, and that would be plus what? 2 h to the 4th. Exactly. 1 times that. Yeah. The minus signs multiply to be plus, and we have any question on that? You see how we do it? Pretty straightforward, right? Now, I bet you they're going to string it out a little bit. Let's see if that's helpful to you. First, the distributive property. They're writing on the mind. They're first going to do the minus 2h to the 4th times the minus 3h to the 9th. Okay. They're going to do it one step at a time now. A minus 2h plus a minus 2h to the 4th times the 8h squared. Then they'll do plus, say, negative 2h to the 4th times a minus 1. Okay? Now, if you take the time, and by all means, take as many steps as it takes for you to see what's going on. You don't have to rush it like we did. You can take as many steps, but if you see it, do it. Notice here, negative times negative is plus, so that's going to be a plus 12, h to the 4 plus 9, 13. Okay? What did I say, 12? 2 times 3 is 6. Okay. Ugh. Okay. Plus or minus times a plus, that's going to be a minus. 2 times 8, 16. H to the 6th. And minus times minus is plus 2h to the 4th. Make sense? All right, good deal. Let's see. Now they tell you how to do it. They showed you how to do it. Oh, no, I'm sorry. Multiplying two polynomials. Multiply each term of the second polynomial by each term of the first polynomial and add products. You know what? Before we do that, I want you to give me some numbers. Okay? Give me a digit, any digit. 4. Another? 7. Is that what you said? Okay, 7. If it'll write, okay. One more. 3. Okay, let's multiply that by, give me a 2-digit number.
12.
Huh? 12. Okay. Now, how do we multiply? If we're multiplying those numbers, remind me how to do it. Don't tell me you pull out your telephone and punch it in. No. I want you to actually multiply. How did we do that? Do you remember? Oh, me, long. Huh? Okay, you do 3 times 2, right? 6. 2 times 7, 14. We carry a 1. 2 times 4, 8. Plus 1 is 9. 1 times 3 is 3. 1 times 7 is 7. 1 times 4 is 4. No, that 1 up there is not a carry. And then we add them together. 4, oh wait, 5, let's start at the beginning. 6, 7, 16, carry 1, and 5. Okay. Now, notice each, okay, now these are digits, I said, but they each stand for something. Ones, tens, hundreds. Ones, tens. So 3 ones times 3 times 2 ones is 6 ones. So that's in the 1 column, right? And 2 ones times 7 tens are 14. So the 4 goes here and the 1 goes over here. That'd be 140. So the 1 here is in the hundreds column. And 2 ones times 4 hundreds, that would be 800 plus 1 is 900. So you see how that works? Okay? And then here this would be 110 times 3 ones. That would be 30. You could put a 0 there if you wanted to. So that's in the tens column. 110 times 7 tens is 700. If you put another 0 out there, that'd be 700. And 110 times 4 hundreds would be 40 hundreds. You know, 4,000, sorry. Yeah. 100 times 10, yeah. 4,000. Put another there. And that's what you got. And then you're adding your ones together. You only have the ones. You're adding your tens together, your hundreds together, and your thousands together. Okay? That's how we do it. We're adding like values, right? You know what? That's how we do polynomials too. Except the polynomials are going to be written horizontally rather than vertically. I like to do a lot more things horizontally than I do vertically. But anyway, I like lying down. But we're going to do it that way, but we're still going to do one term at a time. That's the deal. Just like we're doing this, one digit or one place value at a time. Same principle. Okay? So to multiply two polynomials, multiply each term of the second polynomial by the first polynomial. You could have done it this way. This does this, this does this. You know, you just put them in different places. Okay? And then add the products together. Like terms together. Just like we added here. Multiply each term and then add the products that are like terms. Okay? So let's see if we can do one. Here's one. 2y squared minus 5 times 2y cubed minus 7y plus 4. I'm glad they wrote it twice. It makes it so much nicer to do. But what do? Term by term by term. Okay? So let's do the first one. This one will be what? 4y to the 5th. Okay? Then do the first by the second. And what do you get? Was there a sign in there? Yeah, minus 14. Why? Why not? Okay. To the third. Very good. And let's do the first times the third. And what does that give us? A little louder. Positive plus 8y squared. Perfect. Okay? Now I'm going to do something a little bizarre here, but I hope you'll be okay with it. Then let's do the second one by each of these. And what that's going to be? Negative 10 y cubed. So why don't we put it under the other y cubed? Minus 10 y cubed. You don't have to, but we put it under that before. We just did it because we're used to doing it, but that's exactly what we were doing. Then the second times the second would be, was there a sign there? Positive plus 35y. Okay, now I didn't put it under y squared because it's not a like term. So I moved over and put it there. And then the second by the third is going to be a minus 20. Now this is how I find, because I'm really lazy, and I don't like making mistakes, and I see it better if I line it up like this. What will your answer be? Now you add like terms. 4y to the fifth minus 24y cubed plus 8y squared plus 35y minus 20. Now, unless I did some stupid mistake somewhere, that should be our answer, right? Now, most of the time, I don't see books doing it this way, but to me, this makes pretty much sense, okay? You don't have to. You can string them out and then loop them together, however you see it best, okay? But basically, you just get first term by each of these terms, second term by each of these terms. If you had a third term here, third term by each of those terms, 15 terms, you just keep going, But then it makes the most sense to me is to line them up with other like terms, and that makes the adding pretty easy, right? Except for Red Joy, who likes to add 9 and 4 and get 12, okay? Okay. All right. Let's see how they did it. I think I probably better erase. Y'all got it down, right? So let me erase, because otherwise I think it's going to be writing on top of each other. So let's see what they do first. First is, oh, look at that. They drew their arrows just like I did. They're copying me. Okay, they do the 2y squared times the 2y cubed. Okay, 2y squared times minus 7y. Then they do the 2y2 times 4. Okay, those are the first terms, multipliers. Then you do the next one, which are now blue arrows, and that's, and they, look at that. Well, no, they're not quite copying me, but close. Minus 5 times 2y to the third, minus 5 times the minus 7y, and minus 5 times the 4. Now they're going to run into a little bit of an issue here, but hopefully they'll work their way out of it. Let's see what they do now. They don't do a thing, okay? There we go. All right, so this will be 2 times 2. The numerical part is 4. Y squared times y cubed is y to the fifth, just like we've done before, right? Now, this one, let's see how they're going to do. I would do this one next. Let's see if they do. Yeah, they didn't take much time doing it, but they did. Minus 14 y cubed. I'll probably do that one next. Let's see which one they do. Yeah, they did that one next. Plus 8 y squared. Then they'll come down here and do minus 10 y cubed. Everybody see that? And then they'll do a plus 35y. And then finally a minus 20. All right. Now they've got to combine like terms. See, they've done it horizontally. I like to do it vertically. 4y fifth does not have any other like terms, so that's just going to come down. They don't have any y4 terms, so don't put any in. But the y cubes, they're going to have to combine those two. Y squared just 1, y1, and the constant 1. So it's not going to be too hard to do this way either. Combine like terms. 4y to the fifth minus 24y cubed plus 8y squared plus 35y minus 20. Same answer we got, right? Okay, good deal. Whatever way you see it best, do it that way. If you don't see it, ask me, and we'll try to figure out a way to get it, right? Any questions? All right, so that was example 2. They have a slightly different one in the book, but it's just as good. Do the one in the book. They show you every step. Then do the 2 on the side, 2A and B, and multiply those. That's on page 868. The first example was on 867. Okay?
Thank you.
All right. All right. Here's an example 3. Again, not the same one they have in the book, but similar. Okay? where would you begin here? Okay. I don't quite see 25, but 20, okay. Those two will give you 20. 20 what? Into the fifth. Very good. Say that again. Plus 32 into the fourth. Next. Everybody see that? N cubed. And then last, not last, but last for 4n squared is what? Minus 8. Okay. N squared. Okay, I'm making sure I've got all my signs right. Yes. Okay. Now we start with the second term. What's the first one? Plus 15 n cubed. Well, there's our n cubed here, so let's put it here. Plus 15 n cubed. Next. A little louder. Okay. Did I hear a minus there? Huh? Okay. I'm hearing all sorts of weird numbers. Oh, okay. Plus 24. What? N squared. Everybody see that? Okay. Then the second times the third will be minus 9 n. And second times the fourth will be minus 6. Very good. And now we combine like terms, and to me it's just nice to have them lined up like this. It makes the adding to me easier. What does that give you? 20 n to the fifth. There are no other n fifth terms. Plus 32 n to the fourth. There are no other n fourth terms, but there's 2 n third terms, and what does that give you? Plus 3 n cubed. Help me, help me. A little louder.
16.
Plus 16. Get the sign first. N squared. And then there's nothing. Minus 9n minus 6, if I could write. All right. Looking pretty good. Make sense? Does everybody see how that works? Okay. You see, you don't have to have just a binomial. You could have 4-term polynomial times a 7-term polynomial. Just do them one at a time, one at a time, one at a time, you know, and get them all covered. Make sure you don't miss it. Okay. Everybody got this? Or still writing? No, still writing. Okay. And again, if you like the way the book does it rather than my little loop-de-loops and things like this, go with the book. If you have another way you like better, as long as it's right, you can use it, okay? I don't want you using any wrong stuff, but do use the right stuff, okay? Yes?
Mr. Fowler, why does it make it subtraction at that,
This one right here, say?
yes.
Okay. What you're adding is a minus 12 n cubed that you got up there and a plus 15 n cubed. Now, if I owed you 12 n cubes and I paid you 15 n cubes, wouldn't you owe me then 3 n cubes, right? Yeah. So that's what we're doing. When you're adding sign numbers, okay, if they're the same sign, add them. Keep the sign add them. If they're both pluses or both minuses, okay? But if they're different signs, then take the difference of them, meaning subtract them. But use the sign of the larger one. So since 15 is larger than 12, use the plus here. The difference between those two is 3.
And the same way.
Same over here. If you had a plus and a minus, the plus was the bigger, so you use the plus and take the difference of these two, and that would be 16. Okay. That makes sense? All right, good deal. Let's see if they got the same thing. I think I need to erase, otherwise it's going to be writing on top of it. Everybody got this? I can erase? Okay, let's see what they do. Oh, they wrote them out like you would do a number, you know. Big number on top, little number on the bottom. They're going to multiply. If you like this way better, you can do it this way. You first do the -6. Then you do the -9n. Then you do the plus 24n squared. Then you do the plus 15n cubed. Now come back to the next one. And now the only thing that's a little different here, you don't have an n term here. All these terms are covered. You don't have an n here. So you're going to start this way, but you won't write it down here. You'll write it over here because it's going to be n squared. That's the only difference. If you put in a 4n squared plus 0n plus 3, that would spread it out and make it look better, but you don't have to do that. You can go, well, they don't do anything here, okay? There we go. That's going to be a -8n squared. Don't put it over here. Put it under the n squared term. -8n squared. They like my method. They must have been listening, okay? All right. I didn't quite write it like this, but it works. And then that would be a -12n cubed. You see it? And then the next one would be plus 32 n to the 4th. And finally, a plus 20 n to the 5th. Okay? Now, they started like you multiply numbers together, big numbers, you know, multi-digit numbers together, and did it that way, which is fine. Normally, I start from the left and work my way the other way. It works both ways, okay? Everything does. If you see this better, use it. Then what we're going to do is draw a line and add like terms. 20n to the 5th of the, well, they're going to start over there. -6, -9n, and again, sign numbers, adding sign numbers with different signs, take the difference but use the dominant sign, the one with the bigger value, okay? And then that one will be a plus 3n cubed, plus 32n to the 4th, plus 20n 5th. Is that the answer we got before? Yes. As long as you take right steps on every part, you can put it any way you want to, the way you see it best. Okay? So they've shown you a couple of different ways to do it. I've showed you maybe another one. Okay? So that's how you do these. Just don't forget to multiply each term by each term, always in the process. And it helps if you do it in an orderly manner. Otherwise, you're going to wind up missing one somewhere probably, unless you're very, very careful. So there's example 3. I have another example 3 in the text. So by all means do that first chance you get after class, and then do the one in the margin right after you do that one. So it gives you 2 more to practice on. Okay, any questions? All right. Oh, there's your answer. Now they color it in. Isn't that nice of them? Okay. All right. Now, they have these little blocks. And frankly, I've never really found these blocks to be all that useful. If you like them and see them and they make sense to you, go for them. Okay? They don't seem to be going to cover it on the slide set, so that's in the text. You can look at that. This is the multiplying binomials by the FOIL method. It's just the bottom of page 869, and then they're going to come back and we'll do the example of it. Okay? So, this is binomial times binomial. It doesn't work for anything else. Only binomial by binomial. It's doing the very thing we did before, but this has a little acrostic that goes with it. You multiply the first term. Well, we did the first times the first before, didn't we? So there's your F, okay? Then you do the outer term. So that's the first times the second, which is exactly what we did before. Now we're just going to call them outer terms. Then you do the second times the first. Well, those are the inner terms, okay? So that's where they get the inner, okay? And then finally you do the last term, which is second by second, okay? And that gives you the last term, okay? Now, what they say here, find the outer product and the inner product and add them when possible. There are some times it won't be possible. If you're adding 2x squared plus 7 times 3x plus 4, you're not going to be able to add the middle term, the inner and the outers, okay? Because the outers would be x squared and the inner just x. So you can't do it. So it's only when possible you do that. And then the last term. It's really doing the same thing we just did, only this gives you a little word to go with. Okay? So, let's see if they give us tell you what I'm going to do. I'm going to back off one. And I didn't do this before. I probably should have. On your page 869, they do one before they gave you the method. So I'm going, now that they're giving you the method, let's go back and do it. X plus 3, this is a really simple one, times x plus 5. Okay? And where do we begin? I don't know. Y'all are probably all too young to remember Rocky and Bullwinkle, don't you? Any of your, oh, you remember it? All right. When Boris and Natasha were trying to overcome, which they always tried to overcome Rocky and Bullwinkle, they had it all figured out, and Rocky and Bullwinkle always managed to back themselves out of it and trip them up. And what was it that Boris always said? Curses foiled again. So that's what I think of when I think of the FOIL method. Curses foiled again. Not that it has anything to do with it, but just like that. I always liked Rocky and Bullwinkle. Anyway, for those who haven't seen it, Google it sometime. They're really funny. Okay, Rocky was a squirrel or a chipmunk or something like that, and Bullwinkle was a moose. He was goofy. Okay, so we do FOIL. F is first, and what does that give us? X times x is x squared. Then what's the O? The outer, and that gives us plus 5x. Then the I is inner, and that's plus 3x. And then finally the last is plus 15. And then like they said, if you can combine the innards and outers, do it. That'd be x squared plus 8x plus 15. If you can combine them, it'll give you a trinomial. And if you get the right answer, you get a smiley face, right? Good deal. All right. Make you feel good and warm and fuzzy, right? Okay. All right. Sorry about that. No, I'm not. Okay. So there is how we FOIL. Okay? See it? Okay. Let's move on back to what they told us to do, which is what we just did. And now let's do the example. Example 4, which is at the top of page 470. Okay? 470? 470, right. I mean 870. I don't know what I'm saying. Okay, 870. Okay. Take half of the first digit and say it instead of the real number. I don't know. Okay. So we're going to do, this is not the one that they have in the book, but we will use the one that's on the slide set. Very similar. What do we do first? Y times 3y would be 3y squared. Next. Okay. Y times negative 2 is negative 2y. Next. Negative 12y. The innards are minus 4 times 3y would be minus 12y. And then finally, plus 8. Okay, watch those signs. They like to sneak out and trip you. And what do we have then? Combining like terms? 3y squared minus 14y plus 8. Perfect. Any questions on that? Is it, see what we're doing? Make sense? All right, remember your rules of order of operation. Okay. And let's see what they got. Oh yeah, they're going to show us. It's not the same one in the book. So let me clear that. You got it down, right? Any questions before I erase it? Okay. After a while, you can probably add those innards and outers in your head, you know, if they're addable, if it's possible to add them.
Can you show me the 14?
Okay. What we did here, minus 2y minus 12.
Oh, okay.
This time they have the same signs, so you add them and keep the signs. The minus sign, and you add the two values. Is that what you're asking?
Yes.
Okay. Good deal. Make sense? Anyone else? Good question. All right, I'm going to erase this so it won't write over itself. Okay. See, oh, they even draw theirs like I did. Okay. The y times 3y will be y times 3y. That's the first. The next, the outers, are y times negative 2. That's your outer. Your negative 4 times 3y. That's your innards. And then your last are negative 4 times negative 2. Okay. Now they're going to go to a new page, and you're going to forget what they have written here. So that's going to be a... Oh, no, they're going to write it up there. Good for them. The 4, the first, is y times 3y is 3y squared, positive. And then you have a minus 2y, minus 12y, and a positive 8. Okay? And then the last step is combine like terms, 3y squared minus 14y plus 8.
What page is that?
That's top of page. Okay. Now this example is on the slide set. It's not here. There's a similar example, top of page 870. Very similar, but just different numbers in there. Okay? Now, everybody got it? Same one we just did, but they're doing it a little bit differently, but doing the same thing, just setting it up and spacing it out differently. So again, remember, as soon as you are out of this class and have some free time, do the examples that are in the book, both those on the white page and those on the gray margins. They're gray in my book. Are they gray in yours? Because I don't see your book. I don't think it's much difference. All right? All right. So here's another one. This isn't the same as one in the book, but it's somewhat similar. Okay, multiply n minus 7 times 5n plus 1. What do we do first? N times 5n is 5n squared. Next. Yes, plus n. N times 1 is n. And then minus 35n. And finally, minus 7. And are there any like terms? Yes, so this one doesn't have a like term, so just write it down. And next, minus 34n. Plus 1n, minus 35n. It left you minus 34n. And then finally, minus 7. Okay? Makes sense? You see how that adding of like terms goes. Had a positive 1 n, then you lost 35 n's. So now you owe whoever it is 34 n's. The one you had, and then the other 34 you still owe. This time the smiley face has a little crook in it. So let's see how they did it. They start with the first term, 5n times 5n will be 5n squared. Then they do the outer terms, n times 1 is n. And they'll do the inner terms. Negative 7 times 5n will be minus 35n. And then they'll do the last terms, minus 7 times 1 will be a minus 7. So we combine those together up here. Minus 5n squared plus n minus 35n minus 7. Okay? Then combining like terms, 5n squared minus 34n minus 7. Got it? All right, good deal. Okay. All right. They don't number this example. I guess this is just another example. Okay? What would you do first? 3g times 9g would be 27g squared. Okay? Next. Okay, we'll do the outers, which is what sign? Negative 12 g's. Then, say again? Plus how many? I can't hear. 18, yeah. Sorry, my hearing's bad. Plus 18 g's. And finally, a little louder? Minus 8, got it. Okay, anything we can combine here? No other g squared, so write that one down, 24g squared. And then what happens there? A little louder?
Everything else that, or
The g's here.
6G.
Say again?
6G.
Plus 6g. You can go with the sign of the larger number and then take a difference because there are different signs. And then minus 8 is by itself. That looks like our answer to me. Anyone wants to dispute, negate it? See how it works? Everybody got it? Okay. Let me erase this and we'll watch how they did it. Do it. Okay. They start with the first terms, 3g times 9g. Ultimately, that will give them 27g squared. Not yet, though. And the outer terms, 3g times negative 4g, will give them a minus 12g when we get there. Then they do the inner terms. Plus 2 times 9 will be plus 18. 9g will be plus 18g. And then the last terms will be 2 times the negative 4, which will ultimately give us a negative 8. So now we're going to combine those together, and that's going to be equal to 27g squared minus 12g plus 18g minus 8. And then what can we combine? The g's, okay, not the g squared, the g. So the 27g squared stays like it is. A minus 12 plus 18 will give us a plus 6g minus 8. Right? All right, everybody got it? Good deal. All right, they seem to like these a lot. They're going to do another one. Notice a little something different in this one. You got different variables in each of the terms. You know, the first and second term. So what are we going to do here? What would be your first guess? It's still binomials. So what would it be? 24. 24a squared. Perfect. Then
12.
minus 12 AB. You can't combine them, just multiply them. That's what you're doing. 6 times 2 is 12. The minus is there. And then A times B is AB. Next, the innards. Plus 12 AB. Interesting, huh? And second, minus 6 B squared. All right. What would we do next? Combine like terms. A squared doesn't have a like term, so just write it down. 24a squared. How about your AB terms? They add to 0. And finally you have a minus 6b squared. Wow. Works. Now don't think just because they have two variables then I'm always going to lose the middle term. Just happen to work that way on this one. Okay? Make sense? Now, I don't know. Let's do it. I wanted to show you something about that. And you don't have to do this, but this might just help you see it a little bit better. Notice in that first term there's a common factor, isn't there? Have we've done some factor, or have we done? No, we haven't done any factoring, have we? No. Okay. Let's not worry with it yet. Okay. All right. Let's show how they do it. Okay? We'll erase those. And they do the first ones first, 6a times 4a, which will be ultimately a 24a squared. Then our outer terms are going to be a 6a times a negative 2b, which will ultimately be our negative 12ab. Then our inner terms are going to be a plus 3b times a minus plus 4a, will again be a plus 12ab, because you can write them in any order you want to. And then your last terms will be 3b times a minus 2b, which will ultimately be a minus 6b squared. And that gives you what I just said, 24a squared minus 12ab minus, or plus 12ab minus 6b squared. And when you combine like terms, the two middle terms, the innards and the outers, add to 0, giving you just 24a squared minus 6b squared. Perfectly fine example. It's example 6. Okay. Whoa, that's the last slide of the section. Okay. Okay. Now, again, you have examples in the text which are similar but not the same as these, and they also have the marginal examples which are similar again but not the same. Homework exercises in 13.3 will then be do 1 and 2. That's just matching up. I think you'll see it pretty easily how you get those. Then do 3 and or 4. Okay. Any of the ones 5 through 12. This is page 871. I actually said the number correctly the first time check. Okay. Then any of the exercises 13 to 24. Those are monomials times polynomials. I'd say 13 to 26, I'm sorry. Then do any of the ones 27 to 36. Those are any two polynomials multiplied together. And 35 and 36 have fractional coefficients, which are a lot of fun. And then those rectangle method. Yeah. You can do them if you want to, but don't feel absolutely like it's required to do. It's a pretty simple process. Do you want me to just do one of those? They had some in the text that I kind of glossed over because the slideshow didn't have them, but let's go back and do one of those in the text. This is called the rectangle to model the polynomial multiplication. Here's what we're multiplying. Let's use this one since we've already done it. Let's just go on and use it. What we'll do is 6a 3b, I would call this a square rather than a rectangle, but they call it a rectangle, and 4a and a minus 2b, okay? And then you multiply rows and columns. 6 times 4, 24, a squared. 6a times minus 2b would be minus 12ab. 4a times 3b, 12ab, and 3b times a negative 2b would be a minus 6b squared. Okay? Then you add like terms. 24a squared plus 0, these add to 0, minus 6b squared. I see no advantage of that. It's just as clear to me without doing the rectangle. But you can do rectangles with 3 times 2, 7 times 5. You know, you can make as big or as small a rectangle as you want to. You just have to be more careful looking for those like terms. I don't find this as particularly easy to spot them. It is when they're not across from each other on 2 by 2, but when you spread it out, it gets a little weirder. Okay. Did you want me to do one of those from your homework? 37, 38, 39, or 40? It's up to you.
Yeah.
Which one? Second?
I don't have the book, but.
Okay. Let's do one with a 2 by 3. You want to do 39 or 40? I don't care. Second?
It doesn't matter.
39. Okay. I'm going to erase that one. Whoops. There we go. Okay. And we'll do 39. So this is page 872. And this is 13.3 exercise. And number 39, you said? Okay. 39 is 2x plus 1 times x squared plus 3x plus 2. I kind of don't like it because they're all the same sign, but it's okay. The next one is 2. Okay, if you're going to do a rectangle, you can do it either 2 by 3 or 3 by 2. It doesn't matter. They do 2x and 1. Okay. And x squared, 3x, and 2. I didn't space them very well, did I? Okay, then just multiply. This will be 2x times x squared is 2x to the cube, right? You see, there's nothing different from what we've been doing before. This will be a 6x squared, right? That will be a 4x. 2x times 2 is 4x. And 1 time each of those would be x squared, 3x, and 2. Just multiply 1. You multiply row by column. Every one. Okay? And then we combine like terms. And this is by itself, so we'll just write 2x cubed. These two are alike, so combine those, and that'll be x squared plus 6x squared would be 7x squared. These two are alike. That's 3x plus 4x will be plus 7x, and then 2 is by itself plus 2. Same thing we did before when we multiplied out. If you see this better, by all means use it. Okay? If it's just more to do and you don't want to do anymore, you don't have to. It's up to you. Okay? But in case the test bank has one in it that wants you to do it this way, do it that way. All right. So do either any of those. We did 39. Do any of the other three, 37 to 40. Then do any of the ones 41 through 66. Now again, they did something a little differently here. And let's turn back. You pick one of them, 61 to 66. Can I erase the one I just did? Yeah. No? Okay. But while he's still working, then someone choose one of the ones from 61 to 66. 63? Is that what you said? Okay. All right, to do it now, or are you still, no, you're still writing? 63. Okay. I like that one. Got it? No, still writing. Done? Okay. So let me hurry. And this will be page 873. Again, same section as before, and we're going to do 63. That's what you said, right? That's a 3y cubed times 2y plus 3 times y minus 5. Okay? This is 3 factors multiplied together. Now, you can do it any way you want to. To me, the easiest way is do your binomials first. Full, right? So let's do it. What would be your first one? And since I'm not going to do it yet, I'm going to write down the 3y cubed. Now let's do this one. First will give you 2y squared. Outers will give you a little outer, minus 10y. Innards will give you plus 3y. Always put a sign in there. Okay? And the last will give you a little outer. Nope. Plus minus 15. Watch those signs, right? Okay. Leave that 3y cubed alone for now. Go on and combine your like terms here. And that would be 2y squared. There's nothing like that. What will the other two give you? Next two. 7y, is that what I heard?
Yeah.
I need a sign in there. Negative 7y, excellent, okay? And then minus 15, okay? Now, we just do what we were doing before, distribute. And what will that give you? 6y to the what? 5th, perfect. Next. Next. Second. negative 21 y to the what? Fourth power. Perfect. And then the last is is 3 times 15 is what? 45, did I hear? Anyone go for 50, 50, 50, what? No, that's right. Y cubed, okay. All right, and there we have it. So it's just like we did before, only we're doing two different ones. FOIL first, then multiply the monomial times. You could have multiplied the monomial, this one times that one, and then you'll have a binomial, and then FOIL that. Okay? To me, it's just as easy going FOIL and then multiply. Okay? Any way you want. Okay, good deal. We'll begin next time with 13.4. Special products. As if these weren't special enough. Okay. See you. And we'll start at 1:30. 1:30 on Wednesday. And someone come get me if I forget. I swear. My brain is